Very good evening to one and all. This is Prakash, National Secretary from IIP headquarters. A warm welcome to all on behalf of IIPE for this technical session on the occasion of World Water Day. Now I would like to invite our National President, Mr. Ashish Shekhar, to deliver his presidential welcome address. Over to Ashish Shekhar, Bangalore.
Thank you, Prakash. Good evening, ladies and gentlemen. It gives me great pleasure in extending a warm welcome to all of you for this virtual program on water conservation in industries by 3R method. And this is going to be presented by a very eminent person, Professor Dr. Inayathulla. Prakash will be introducing him later. We all know that water is one of the most important ingredient for all the life form in our planet, for their existence. And human beings, by our indiscreet actions, we have endangered the availability of this important resource. The water sources are fast depleting, and if we continue to go at this rate, we are bound to see a zero day. Hence, water conservation is to be taken up on topmost priority, and it is the need of the hour. Today, Dr. Inayathulla will be addressing us on this important subject on water conservation and method to conserve. And one drop of water saved is one drop created. With this, I request our National Secretary, Mr. Prakash, to introduce the speaker, Dr. Inayathulla, to the audience, and I request Dr. Inayathulla to address the gathering. Thank you.
Thank you so much, sir. It gives me immense pleasure to introduce Dr. M Inayathulla. He is a Director, Water Institute and Professor, Department of Civil Engineering, University of Visvesvaraya College of Engineering, Bengaluru. He has done his BE Civil Engineering, ME Water Resources Engineering, PhD in Water Resources Engineering. He is also the technical advisor to Stormwater Drainage and Lakes of Bengaluru Corporation, technical advisor to Stormwater Drainage, technical advisor to Lakes, and also is in the sectional committee, Water Resources Department, Bureau of Indian Standards, New Delhi. He is former technical committee member, Central Groundwater Board, Bangalore. He is also NSS program officer of Visvesvaraya College of Engineering, University, Bangalore. And he has been a member of various state level technical committees, advisory committees, and he is also in the master plan of Bangalore Development Authority. He is coordinating with Central Water Board on the field of training and painting competition, technical advisor to skill development of Islamia Institute of Technology, Bangalore. He is also Karnataka Secretary of Association of Muslim Professionals, Bengaluru. He is founding member of Skill Development Education Research Trust, Bangalore. And his career spans more than 30 years in teaching, undergraduate, postgraduate, research scholars. He has researched and published more than 100 research papers and technical journals in the conferences. He also undertakes a technical consultancy, third-party inspection for various authorities and Bangalore development boards. He has so far supervised more than 10 doctoral degree candidates and also more than 5 people working under him now. He has done a lot of consultancy work. He has been to the project management consultant to the Bangalore Development Authority in restoration and overall development of lakes, tanks of Bangalore Development Authority. And he has handled the projects more than 100 crores on the impact assessment studies and the Central Groundwater Board Bangalore, and also in the institutional cross-disciplinary policy analysis of water quality, quantity, watershed management of Kolar district, Karnataka state, in collaboration with ISEC Bangalore. He had been involved in the construction of sewage, drainage, sewage treatment plant, major pumping stations in the rural areas of Bangalore. Also in the sewage treatment plants of operation residential areas, construction of hopper tank, buffer tank, holding tank, irrigation storage tank, and a lot of activities. He was involved in the pressure pipelines, gravity lines, regeneration of open wells. Really, I feel he's a really expert today on the right occasion of World Water Day. He has also been with the artificial groundwater recharge of Janaparathi of Ministry of Water Resources, Government of India, and also with the third-party inspection in the Rural Water Development Scheme of Karnataka, Rural Water Supply and Sanitation Agency, Government of Karnataka. With all these experience, he is also member of professional bodies like Association of Geoscientists for International Development, life member of Indian Society of Technical Education, New Delhi, life member of Indian Association of Hydrologists, life member of Indian Society of Analytical Scientists, life member of Indian Society of Remote Sensing, life member of Indian Water Resources Society. Of course, he is life fellow of Iipe, Indian Institute of Plant Engineers. A warm welcome to you, sir. Good evening.
Good evening.
Please enlighten us. Tell us about the water conservation on this World Water Day occasion. Over to Dr. Inayathulla. Thank you so much, sir.
Thank you, sir. I'm audible, sir?
Yes, sir. Please go ahead, sir.
Yes, sir. Respected Narasimhan Prakash Sarji, National Secretary, IIB, our National President, our C. Shekhar Sarji, I think our Professor Shashi Shankar sir also may be there. So I am really sir, I'm thankful to IIP for giving me this opportunity. I'm going to share my slides. Is it clear, sir?
Yeah, clear, sir. Please go ahead.
Yeah. So I'm thankful to Indian Institute of Plant Engineers organization, particularly Prakash Sarji and our Shekhar sir for giving this opportunity. Already the more introduction has been given by our Prakash sir. More so since I am involved in BBMP and particularly regeneration of lakes and water conservation, and today's World Water Day. So welcome one and all to today's 22nd March World Water Day, and theme of this World Water Day is Water for Peace. So this World Water Day, the other themes are the answer to the nature, leaving no one behind, water and climate change, valuing water, groundwater, accelerating change, and this year, 2024 World Water Day, the theme is leveraging water for peace. All these things comes under conservation of water and prevention of water, management of water, and now this time it is a water for peace. So this year, theme for World Water Day is Water for Peace _ the fundamental role that water plays in promoting harmony, among nations, communities, and individuals. Today, as we reflect the significance of water in promoting peace, let us reaffirm our commitment to sustainable water management practices. So important is sustainable water management practices. Let us try to conserve and protect our water resources, ensuring equitable access for all, both now and for future generations. So World Water Day 2024 is about working together to balance everyone's needs with a dedication to ensure no one is left behind to make water a catalyst for a mere a more peaceful world. So it is a more peaceful world. In Bangalore, nowadays, this year, we are facing a lot of drought. Maximum of our borewells got dried up, and our particularly surrounding area, central Bangalore is okay, but its surrounding area, it is suffering completely drought. And I say 257 or more than that locations, our borewells has already at high risk. Responding to this, our Bangalore Water Supply and Sewerage Board, BWSSB, issued an order on March 8, 2024, prohibiting the use of drinking water for washing vehicles, gardening, and construction. So remember this potable water we cannot use for washing vehicles, gardening, and construction. So this is the situation in Bangalore. Now I can see in Bangalore, so the amount of what is groundwater extraction, particularly in urban Bangalore, in Anekal, Elanka, Bangalore city and all. So now the values, see that 125.68 billion liters of water, annual groundwater availability is there, but extraction is 188.54 in 2013. And you can see that it has gone on increasing, and 321.98, we have done more extraction than its recharging values. So in urban rural areas, also the same case, you can see that the availability is 188.11 billion liters, but extraction is 289.69 in 2023. And the same thing in all these years in annual groundwater extractions from rivers. So the key aspects includes reliance on overexploited groundwater, limited access to BWSSB pipeline in Bangalore particularly, neglected lake maintenances, and underutilization of water treatment facilities. Major is our water bodies has not maintained properly. It has been polluted, and we are not using the wastewater, the reuse of wastewater, and more stress is on groundwater, and due to which it is over exploited. And this year, particularly in Bangalore and other areas, we are feeling very heavy drought. So you can see here the sources in Bangalore, in Karnataka, particularly in Bangalore, Kaveri, we are depending on 1,460 MLD of water, whereas the groundwater we are using 1,329 MLD. Kaveri water, which is at low level, we are pumping to higher level to Bangalore, and we are supplying Bangalore Water Supply Sewerage Board 1,189 MLD for domestic purposes, and for private bore wells 1,332 MLD. Commercial and institutional demand is 205, and industrial demand in Bangalore, particularly 441 MLD, and construction 78, and green space demand 24 MLD. So wastewater treatment in Bangalore, you can see domestic 1,512 MLD. It is wastewater produced, and wastewater produced in commercial and industrial is 164, industrial is 265. Wastewater not treated domestically 280, and commercially and all, no treatment at all. And industrial, it is 260. Whereas wastewater reused, that is the major part we are leaving. See that in industrial, it is almost zero. There is no reuse of wastewater. So water conservation, why should we do it? And more reasons than a drought. It is not only a drought. It is a water conservation is important. It is not only satisfying the drought problems, But why it is important to conserve water? To guard against rising cost and potential, to preserve the environment, to prepare future droughts, and to strengthen the communities. So water conservation is defined as any action that reduces the amount of water withdrawn from water supply sources, reduces consumptive use, the evapotranspiration and continuous use of that reduces if you do water conservation, reduces losses or waste of water, improves the efficiency of water use, increases recycling and reuse of water. These are the meaning. If you adopt all this in the context, but that is the benefit of importance of water conservation. Prevents the pollution of water. Therefore, it minimizes the need to fund expensive reservoir water treatment plant and pipeline project. If you conserve water, it minimizes and it reduces water wastages, improving water use efficiency, promoting agriculture, industry, and domestic users if you conserve water systematically, technically, and we involve in management of our water. So the importance of water conservation is its sustainability. By using more efficiently and responsibly, we can help sustain ecosystem and support biodiversity. And we can answer water scarcity. Conservation efforts can help elevate water stress and ensure equitable access to water for all. It mitigating the drought impact, and it also climate resilience if we do the conservation. By managing water resources more sustainably, we can build resilience to impact of climate change and ensure a more secure future for all. So global industrial water use, you can see that in high income industries, for domestic it is 11% demand, industrial use it is 59% demand, agriculture 30%. Whereas low and middle income in countries, the domestic use is 8%, industrial use is 10%, agriculture use is 82%. These are the global scenario. If you go to global water budget, so you can see that if you 100% of the global in water, 97% of global water is saline. That means its PPT is 35 PPT or more than that. And the permissible limit for drinking is 0.005 ppm, whereas salinity is 35 ppm. So in that 97%, only 3% we get fresh water. So this shows the importance of management of conservation of water. Only 3% of 100% of global water is available as a fresh water. In this 3%, 68.7% is in the form of ice cap and glaciers. And groundwater is 30% of 3% of 100% of the global water. And surface water is only 0.3%. The surface water is 0.3% of 3% of the global water. And you can see that in this 0.3%, lakes are 87%, swamps 11%, rivers 2%. So these water bodies, surface water bodies, we add our groundwater. These two management are very, 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 very crucially important, and conservation of these water bodies are very, very important. You can see the importance of this. The fresh surface water, how much? 87% of 0.3% of 3% of the global water is only the water which is available. So conservation, we can see the importance of conservation. You can see that our low-lying areas, lakes and downs into floods in Bangalore. November 22-21, this is a Kendriya Southern in Bangalore has subject to flooding. And Bangalore, Yelahanka, that is the Kendriya Southern. This is the flood, we can see that. And this is the Kendriya Southern. And it's, this is the project we have done this. I'm also a part of this PBMP and as a technical hydrologic advisory from past 10, 15 years there. See that this is an Yelahanka Lake. Yelahanka Lake, and this is the complete, and it is on the upstream is Yelahanka Lake, downstream is Kogilu, and its downstream is Japur Lake. Now you can see this is Yelahanka Lake, this is the Kendriya Southern, this is the Kogilu layout, and this is the Japur. And you see, these are the one outlet. This is another outlet. These two outlet passes like this, and it passes from here and from this Kogilu, and it is the drainage system, water drainage passes like this. and it enters into the Jaipur. So like this, almost all our water bodies are cascading system. Very good cascading system is there. Surplus of upstream will fills the down surplus of, it means it fills the water bodies of the downstream. But here, some construction activities was going on, due to here at Kogilu, it has obstructed, and this what is that outlet is got obstructed. So during this rainfall, heavy rainfall, this flood, the water from here completely enters into the Kendriya Sadan, enters into this completely Kogilu, and what you have seen, the what is that the flood in this year, this whole area got highly flooded. It shows that it is not a problem of a flooding, it is a management problem. It is a completely, it is a obstruction, non-clearance of our stormwater drainages, encroachment of our stormwater drainages causes the floods here. Once we treated this, recently, again it is flooded in low-lying areas, but this area is safe from the flooding. That means it is all the problem has been removed, and then later on, this is not subjected to the flood. So this is the this is the Kogilu which has been affected only because of the mismatch. That means it is the obstruction and encroachment of those stormwater drainages in the lakes. And you can see the Bangalore. If you see the remote sensing, means the views, it is greenery, completely greenery, and maximum pervious area was there, and rainfall. It was, what is that? It is infiltrating and it is recharging the groundwater, and it goes on slightly, it goes on concreting. Even 2020 itself, you can see that I have not shown you 2024, but 2023, this period, 2022 itself, you can see the complete concretization. What is happening? There is no recharging, there is no impermeability, percolation meeting the groundwater, and this causes the, what is that? The groundwater, that's, we are losing the groundwater recharge, and there is no infiltration. And as soon as the precipitation occurs, it suddenly we see the flash floods and in the our areas. And you see that almost all our rivers, though we have taken lot of what is that technical applicability is there, is the situation, the management. You see that these are the area, and almost all our storm water contains the underground sewage waters also. If sewage water doesn't work, again it acts as a sewers. And this is the team. We are the team members of stormwater drainages of Bangalore. We had done the inspections of all these areas. And you see recently, these are the rainbow layout. It is a very high costly layout. In Sarjapur, it has been completely flooded. See that, and this is due to metro again, because of the obstruction of all these drainages, and urbanization. Due to urbanization, all these drainage system has been affected. Now we cannot simply depend on topo sheets or something. We have to prepare the new urbanized drainage map, new digital elevation map, and we had to remove encroachments and all. These are the problems, which is what is that due to mismanagement, all these flood problems. Now this is the Bangalore. You can see that rural area, there is Arkavati Valley is there. In our urban area, there are three valleys: Abboud Valley, as well as the Rishmavati Valley and Kormangla Chalgatta Valley is there. So you can see that this is the drainage. The upper stream, they get, what is that? These are the cascade system. This goes to the Yelanka, the surplus goes to Jakkur, and Jakkur surplus goes to Rachanalli and all. I was in charge of this Jakkur and Rachanalli and Venkateshpura in 2006 and 8. It is what some 100 and some 10 projects we have created. What is that? We are rejuvenated. And you see the surplus goes to Jakkur, and from this Agra lake, it comes to Jakkur, and from Venkateshpura lake, it comes to Jakkur, and these two outlets goes to again Rachanalli, and like that, these are the system. You can see that this is the village map, and these are the rejuvenation map, and this is deep. Now, I think it takes some time then. I am having a lot of figures to show. I am audible, sir?
Yeah, please go ahead, sir.
Yes, sir. Now you see, sir, this is a Jakkur Rachanalli lake, and this is the outlet. See that this is the outlet in during flooding. You see that this is the water, the outlet was flowing like this. It meets both the Jakpura and Sampagangi, so we call Jakku Sampagangi Lake. Now this has been completely pipe culvert has been designed, and the immersion tanks has been designed, and this is dewatered, and also this is see that this is the Rajanadi Lake, and all this is one what is sewer which was the low flow we have diverted to the downstream, and the surplus it is coming in top. So like that, all the lakes, I'm not going in detail of those things, simply to show that the regeneration work has been done. In Bangalore, the before, this is the Kalkare Lake as well as Kembabudi Lake, and after rejuvenation. Um, so I will take some time. Okay. Now, this is what we have done, that we not only rejuvenated, Central Groundwater Board, she is the scientist from the Central Groundwater Board, and they have drilled in almost upstream as well as downstream of all these water bodies, and they have installed the piezometer, so that we wanted to measure, because these urban lakes now no more irrigation lakes, they are only water recharging lakes. And what is the corresponding water levels to monitor? We installed piezometers, and we are monitoring both piezometers as well as the this one water surfaces of these bodies. And since I was in charge of this, I have taken a research projects also, 2, 3 PhDs I produced on these water bodies. And he is the Professor Paul and Prasad, both are now the professors. They have done it, they use the isotopes, and they collected the samples of what is that Elanka lakes, and the samples means surface water, and surrounding the located the groundwaters, and they have located, and they have collected these surface waters as well as groundwater samples continuously. They monitor in different seasons, and also they have taken rainwater they have collected, and also using ice. They have see that they have installed the rain gauges also. Using ice, they have taken the moisture also. So using this, the isotopes they have measured, you see that at different depth, we are collected the water samples and rainwater, and here you can see the ice which attracts the moisture, and finally the moisture will be collected. And these samples, you see, this is the ice, it collects the moisture, and this moisture it goes and it collects into the water, and this bottle as well as rainwater, surface water, like this, these water samples has been collected, and these water samples has been analyzed for isotope, for deuterium, how much deuterium is there, how much what is that oxygen O18 is there, then fractionization. And this helps us to show that whether which is the source which is recharging the water, which is whether it is surface water or directly it is getting recharged with the rainwater, or which are the sources. So like this, the identification of the water has also been conducted. See that the samples which are coming nearer to the meteoric line, we can say that it is the surface water which has recharging. Otherwise, it is the other surfaces or rainwater or any other source is being calculated. So this is what I wanted to show. Actually, for me, our Shekhar sir has given the topic is water conservation industries through 3R. This is the actual subject by reduce, recycle, and reuse methods. So what I have shown so far is the water bodies, lakes. Why I have shown, I have not gone in detail of those water bodies and lakes. Simply has shown that we have done these constructions and all the recharging, as well as we are monitoring the piezometers for the conservation purposes. But and we know that the importance of water bodies, the surface water bodies are very important for the conservation. In industries, again, we have to use the reduce, recycle, and reuse method. So in industries, water conservation is critical for sustainability. This involves reducing, recycling, reusing water to minimize. See that these are the natural. So what is that? Water recycling is a critical element for managing our water sources. Through water conservation and water recycling, we can meet environmental needs, still have sustainable development and a visible. This is the general method. I am not going into the treatment and all. This completely shows secondary treatment, tertiary treatment, and water treatment, water recycling. and it all, or these are the procedures to be adopted. Water polluted by industries for iron and steel, pulp and paper, mining, chemical, all these pollutants has to, means these are the pollutants which is coming out of this. This pollutant has to be recycled and means utilized, and after treatment only we are, instead of recharging, it can be reused or we can utilize for recharging. Right? Like that, these are the procedure. So heavy metals are generated in electroplating, electrolysis, deposition, conversion, coating, iodizing. Heavy metals waste like tin, lead, and nickel results from printed circular boards and wood processing industry. These are the pollutants which are happening there. In heavy metals, these are the arsenic, cadmium, chromium, and so a lot of importance is required for industries. They have to have a very good the treatment plants and effluent treatment plant or common effluent treatment plant, and that they have to do a lot of recharging as well as utilization of recycling of water and using this. So this I am not going to this. So importance of reduced water usage. So cost efficiency, reduced water usage leads to lower operation cost, sustainability, conserving water aligned with environmental sustainability, and regulatory compliances. These are the industries, they have to concentrate more on cost efficiency, sustainability, and regulatory compliances. So if you come to a watershed, so what is there? Again, from industry, I'm not going in detail of what is the because what is the pollutant and what are the treatment. Everyone are so good. Only important is here concept is the conservation. Now you can see that the complete, we want to see that we have to do water balance study, hydraulic water balance study of each micro watershed. Now you can see that this is the, if we say this is the state and what is the inflow to here, outflow to here, what is the recharging aquifer, how much the demand for industry, what is the demand for irrigation, what is the demand for agriculture use, what is the demand for hotel industry, or what is the demand for domestic residential industry. The whole thing, groundwater, everything has to be calculated. This is the work I had done for the National Water Commission. We had done the whole water budget for the water commissions. National Water Commission, it is uploaded in the water commissions. These are the watershed of Krishna, Godavari, and Kaveri, and all these are the river, what is it, watershed of Karnataka and their area, and these are the climatic data to be calculated. And this is our college, UVCA, and this is our hydro, what is that, meteorological stations installed, and we are completely monitoring rain gauges, evaporation, and what is radiations, all these things managing with in association with WRDO. So these are the hydrometeorological stations. So I had to say these are the different meteorological, the parameters has been plotted and corresponding runoff has to be calculated, corresponding temperature, and then we can see that what is the climate effect on rainfall, climate effect on runoff, climate effect on agriculture, like that. All the studies and all can be, has to be done using this monthly climatic variations of Karnataka. This is one of the figure. One of the is rain gauge stations or meteorological stations to be done. Now you see that like that we have done for the complete all the basins, the annual flow for Kaveri Basin for different months for the whole year. See that for Krishna Basin, West Flowing Basin, these are the data. This is the calculations calculated for that rainfall of annual rainfall of all the basins. And you can see that this is the Krishna Basin and all the rain gauge station is located this of this teaching polygon and finding the average. And this is Kaveri Basin, and this is the Godavari Basin, this is the West Flowing Basin, the Pennar Basin, and South Pennar and Palar. Like this, the precipitation has been calculated, the yield has been calculated, our resources is calculated in each basin. What is the precipitation? What is the yield? What is the total yield in MCM? What is the total yield of water available in Krishna Basin, in Godavari Basin, in Kaveri Basin? And this helps us. If we know the water balance, we can, if we know the supply, we know the demand, we can do the management, and we can has to do this complete study at micro watershed level. This is the complete watershed level of the country. And these are the rivers flowing. These are the rain gauge station connected. And these rain gauge stations is monitored. And you see that for Godavari basin, all the rain gauge station, the observed by Central Water Commission, the rain gauge, the green shows, the point shows the stations measured by, means observed by WRD. Like that, for west flowing rivers, all the rain gauge station data is taken. Stream gauge just in Kaveri Basin, all the Kaveri Basin rain gauge station data has been collected, and stream gauges in Krishna Basin, all the red CWC and green, it represents WRD stations and streamlines, and this is the complete Krishna Basin we have taken. Like that, monthly minimum flow observed in Kaveri Basin. So what is that? In 91, 92, 92, 93, all the flows has been observed, has been calculated, and from that, what is the flow is going on, and what is the flow in from Kerala to from other states to Karnataka, and the Krishna Basin maximum, what is the flow, and what is the minimum flow we are supplying to Karnataka, and from we are leaving to Andhra, what is the minimum flow we are leaving to Tamil Nadu. Like that, the complete study runoff from rainfall within the sub-basin, inflow from upstream states, and water mandatory to be released to downstream state. What is the groundwater availability? What is the water availability? What is the total water? So that from this we know what is the budget of water, what is the quantity of water available for us for planning for different activities of our future. For this, the demand has to be calculated. In this demand, drinking water and domestic for each basin, for rural drinking, what is the demand? What is the urban drinking demand? For basin-wise water demand for farm sectors. This is the farm sectors demand in all the basins is calculated for crops, how much, for livestock, how much, fisheries, how much, grand total it is there. So like that, why I am showing this industry and infrastructure demand. This has to be improved further. It has to be calculated. Even we have gone to all the industries here. We have gone to even particularly for railway department. We have collected more that metro, how they are utilizing, why, how they are treating, how they are conserving, how they are recycling, and how they are reusing in rail and wheel axle in Lanka. What is the quantity they are using, how they are conserving. All this data has to be calculated. This helps us in demand calculations. See that establishment and institution demand in MCM for universities, in schools, in hospitals, in hotels, in restaurants, in golf establishment and institutions. Like that, the basin-wise water demand, forest, farm sector, livestock, fisheries, industry. For industry in each basin and establishment and institutions, other institutions for drinking water, rural water, grand total of this. Like that, using water demand, water supply, and what is the net, we are facing negative in almost, except in west flowing rivers, we are having negative in almost all the basins. This is the water balance, and it has to be improved. And this is not necessary only to be done in a basin level. This has to be done in micro water basin level. Since why I am explaining all these things is all industries, they have to plot their own micro watershed, and they have to protect their water bodies there. And when treated water, either they have to recharge, or they have to reuse, or recycling and all. And they have to do the water balance of their each water sections. So these are the strategies. I'm not going because I think I have taken more time. Optimizing process, monitoring systems, employee training and data analysis. These are the strategies for reducing water usages. And this is resource conservation, cost saving water, waste reductions, and how the recycling, wastewater treatment, first circulation, second circulation, third circulation, fourth circulations. And important now, even now, what we are facing in Bangalore, particularly, so we are all our water bodies have been polluted, and what we have removed the sluices. Our stormwater drainage has been affected. If you improve that also, if then what is happening? There is due to flash flood, the only surplus water goes to the downstream. So our due to our STPs or wastewater, almost all our water bodies are perennial. It is filled up. So when during high flood or the precipitation and rainfall, there is no space available in our water bodies or surface lakes to catch this extra flood water. So now we have a plan to have a sluices for the openings so that we can keep empty all these water bodies to catch the this rainfall, the floods, as well as if it is secondary SDP water we are passing through the wetlands and then entering into the main bodies of the water body, then we can use the tertiary level and we can use this as an alternate source that reduces the stress to groundwater, that reduces the stress to our rivers. So we can use our, if we properly utilize the recycled, our wastewater. These are the concept. Zero, this is ZLT, liquid discharge is there. These are the concept. Choose recycle of water, advantage and of reusing water industries. Environmental stewardship is there. Reusing water demonstrates a commitment to environmental stewardship and sustainability. Optimizing, maximizing the use of water resources is required. Technical water use in industry. So these are the treatment of the waste may consist of all combination of some of the following process: grid chamber, clarifier, effluents, and so mechanically cleaned circular clarifiers and 95% removal of settleable solids, BOD. All these are the treatment. I'm not going in detail of the treatment. We are concentrating on water conservations. So just to go through that, so different treatment can be done, and what is that technology is available. Only will is required, will of conservation is required, will of reusing of required, will of minimum it, what is wastage of for this, what is that this reused water can be used for our irrigation purposes or sprinkling purposes, lawn using purposes, or even for cleaning purposes. So that we can reduce the stress to our fresh water, potable water. So implementing sustainability, adopting sustainability practices such as rainwater harvesting, on-site sewage treatment plant can reduce the reliance on municipal water resources and bring down water usage in industry. So that means the industry role is more if they all industries comes out and they take charge of these STPs of their own and they use this reliance that what is that recharging and what is that ownership of these water bodies surrounding them, that sustainability will come and that reduces the stress to the municipalities. So water withdrawal reduction, water consumption reduction, water recirculation. See that recharge, okay, groundwater level increasing is also okay. But if you use properly the surface water, we can minimize the energy. You see that there is no need of pumping from to such a high level, groundwater level, so which are already gone 1,000 feet up to 1,500 feet and all. So that energy saving can be done. So more importance has to be given to our surface water bodies. Surface water bodies can be utilized for these purposes. So need for new approaches. See that moving from waste supply, water supply management to demand management. So important is moving from water supply management to important is to satisfy the demand management, conservation and intelligent use of conserved water, watershed management approaches, measuring, restoring stream flow, ground surface. This interaction is very important to be studied. Ground and surface water interaction, facilitating best use of our scarce supplies. So these are the rainwater harvesting is the major part. Use of produced water, use of wastewater harvesting. See, these are the what is that rain filters. We are the parties who what is that wetting all these rainwater in our departments. See that all the benefits they bring their filters here and they get tested here and we test them and we utilize this. And this is a project we use for isotope and isotope hydrology in the Bangalore city. And this is our university, which is more than 1,000 acres. We have developed a biopark here, many recharging structures, and these recharging structures are check dams we constructed, not for irrigation purpose, only recharging purposes. And we have seen the surrounding areas. The surrounding area is a soil sports authority of soil, SIA, that is sports authority of authority, and as also in downstream, almost all the borewells and means groundwater level has increased. We monitor this. Around 7 to 8 check dams we constructed here. See that we had, this is a vertical shaft. What happens, this pond, if the water level increases to this full tank level, then it enters and it recharges the confined aquifer. And this is the confined aquifer recharging pools. And this is the, again, the we are see the drainage. these are the stormwater drainages, which has been complete with. You see that this is one of. So, so what I want to show is this is the one of the main stormwater drainage K100. We proved that this is the survey conducted by drone, and you have seen that almost maximum areas has been encroached, and many buildings has come over the stormwater drainage, which is illegal, and that has been completely removed. This is a completely K100 stormwater drainage for them, and these are the what is that the levels and all. This is the improved stormwater drainages. See that the old one and the improved one in Wilson Garden and all, these are the improved one. Uh, the drainage systems is being improved. And this is one of the, what is that borewell in our department. All the roof water is collected and it passes through. It passes through the filters and then there is a storage tank. From that storage tank, it enters into the perforated and through that it recharges the ground. These are the vertical shaft is being done. And this is a Coca-Cola company has given some 50 crore rupees project for them. Whatever amount they have using the quantity of water. They have to recharge the water. This is the near Bidadi, Delhi Gutta Lake. These are our MTech as well as Central. They are the scientists from Central Groundwater Board. We did the resistivity. Other side, we have done complete rejuvenation of this water body. And these are the resistivity 3 vertical shaft has been constructed. See that this is the vertical shaft. And you see that this is the full tank level, bed level. Full tank level is this one. And once the water level rises the full tank, it enters into that and passes through the filter and it stores here. Then it recharges the confined aquifer. This is the one we have done. These are our final year students who did the survey and they did all this survey. And this is the waste surplus we are of this. But now you can see this. So like that, what is there is, you see that the surplus water can be recharged to the direct vertical shaft to the groundwater. And this is completely our Kaban Park. Kaban Park also, they have done some what is that, smart city approach was there, but hydrology they have not done. So that the hydrology, that infiltration and a small infiltrate recharging pits and all, the complete study has been done. Like that, this sir, still time is available for me. See that this is the Hesarghatta Lake. You can see this Hesarghatta Lake, which was completely satisfying the demand of once Bangalore and the Hesarghatta as well as DJ Halli was the some water sources. Now it was almost dry. And he's our one of my friend. We did PhD under me. He was BJP MLA also. Means he was MLA at present also. He's MLC and it is his PhD work he carried out here for this teaching and all for irrigation purposes. So these are the activities. This Bureau of Indian Standard has come up, and this is the work the program we had done for coding. We can do the coding. All these regeneration activities needs the coding and all, and the works is required. And what we had done, this is that program was to standardize to create the what is the awareness of this coding or modification of coding. so that other agency has to come to develop the Bureau of Indian Standard ISE codes to go for this. And also we have taken a Wipro project where we are giving the projects to all the students, the engineering college students, so that they have to monitor their watershed. They had to do the solid waste management also. They had to monitor the groundwater also. They had to take the samples, both groundwater samples as well as the surface water for what is that qualitative analysis as well as quantitative analysis. So this is they see that these are the watershed and these are the college. This is a presidential college. We are given a project so that they have to monitor this whole watershed. Like that, each watershed, all these college students, they are doing engineering students as well as science students. They come up with very good innovative ideas for conservation of these things. This is the WISE project, Water Institute Scientific Excellence project we are doing for this. And these are the groundwater level. And also, this is the metro. This is metro. We have taken all the metro groundwater levels. And these levels has been measured. These levels has been calculated. And see that this is the water level indicators. And all these universities, they hired an MOU with us. And they are measuring both open wells, bore wells, and they are matching with our metro data. So this is a lot of studies are there. Sir. See, this is one I wanted to show. This is real wheel factory in Karnataka, Lanka. This is the present scenario where in Bangalore, almost all our maximum our more than 257 bore wells are dry. We are facing drought. See the water level in Lanka. In this is in rail wheel RWF of our factory of railway department. Rail wheel factory does what Bengaluru should do. It has to do clear, trash, collect rain. Ecosystem was created in this rainwater. Sustain environmentally. Rail wheel factory sustain environmentally friendly practices and rejuvenation of its open wells and ensure that rail factory Elanka is a comfortable position on waterfront today. It self-generate the required 2 lakh liters per day for its factory, saving 20.65 lakh per annum. This is the present today's state. This has comes in papers also. It is the present state in water bills. They are saving 20.65 in this industry, just conservation of water by doing the conservation of water. So on an average, the rail wheel factory Elanka churns out 600 wheels, 250 axles, and 250. This is one. See, like that, our Yeshwanthpur Railway is also doing a very good conservation. Like that, we have done complete conservation studies of the adopted, the best practices adopted by all these industries. Now see that the sprawling factory spreads 191 acres requires lakh of liters on a daily basis for cooling purposes. So in addition, a sewage treatment plant that can treat up to 300 kiloliters of wastewater per day. Rainwater, this railway, the RWF stadium and other non-potable uses. There are plans to upgrade this plant to 500 KLD and to add another 100 KLD plants in this system. Rainwater harvesting structure channelize rainwater directly to water network in the process. So this is the benefit. So water audit is very important. See that water audit of each industry is very important. Comprehensive analysis of property and water. The aim to identify the identity areas of water waste and inefficiency, providing recommendations for improvement that can be reduce water consumption and save money. So water audit, a tool for water conservation in industry. So significance of water saving, active contribution to conservation, minimize environmental impact. So by doing water audit. So IIPE has to do this water audit. IIPE has to conduct complete courses for the treatment plan and conservation courses, water conservation courses, STP management courses, plant management courses, and see that this is domestic water audit, institutional water audit, commercial water audit, municipal water audit, industrial water audit. So this gives you water audit, process integration, as well as water recycling and all. These are the procedure. So I am going fast. So that in today's world, where water scarcity is a significant concern, companies are striving to minimize their water footprint. Industrial techniques for water conservation are vital to optimize water usage. By adopting innovative technologies such as real-time monitoring and efficient water reuse, companies can reduce their water consumption and save cost while promoting sustainability. Importance of water conservation, reducing water waste, optimizing water use in the industrial sector is a crucial to reduce water waste. Implementing eco-friendly methods such as rainwater harvesting and recycling wastewater can help companies to conserve water and minimize the utilizations. Benefit of water conservation. Apart from reducing environmental impact, water conservation practices can also enhance operational efficiency and reduce operational cost. Companies can achieve sustainable growth by adopting water conservation methods in their operations. So conclusions and key takeaways. Effective water conservation in industry involves reduced usage, recycling, and reuse, benefiting both the environment and operational implementation. These strategies is crucial for sustainable water. These are the programs. Even legal authorities have joined with us to conduct to create the awareness program. Even Prince of our Mysore has joined for public response for creating awareness for these water bodies and conservation of waters. These are the scientists from ISRO and also the churches joined for this purpose. We conduct many courses like lake management and region online courses for these purposes. And even the Chief Justice has addressed with us. These are the courses we done. And these are the integrated water show. But this is isotope hydrology projects we have done this program, flood mitigations, and even water utilization of this. And see that international conferences on sustainable water and wastewater and energy management. This is the programs we conducted this one. And this is very important. The conservation and capacity is most important part. And the industry has to come forward. They can do a lot of the better work than other people. So the industry has to take up this conservation, not only in for industry, their complete catchment area of their surroundings. They have to demark their micro watersheds and do the water balance system of their micro watershed. That is my submission to all the industry people. That is the goal. Think outside the box. Thank you. Thank you very much for giving me this. Thank you, sir.
Thank you so much, sir.
Thank you, sir. I think I'll take more time because